right, I'm going to close the breakout rooms. All right, I think we can get started. I'm going to go ahead and introduce our first speaker today at Roger That. Welcome, welcome. It's wonderful to see you here. This is Michelle Francl, Dr. Michelle Francl. She is the Frank B. Mallory Professor of Chemistry at Bryn Mawr, and she's been there on the faculty since 1986. I think I got Jeannette Piccard on my mind because I almost said 1896, which is not true. And you've also, she is also a quantum chemist, and she's published in areas ranging from the development of methods for computational chemistry to the structures of topologically intriguing molecules. She also does a lot of writing and blogging, and we met at the Vatican Observatory. So I am very thrilled to see you here, and I thank you and looking forward to your presentation. I'll turn it over to you, and you can share screen.
Thanks so much for that wonderful introduction.
You're welcome.
Can get screen up. There we go. All right, so the topic of my talk today is to boldly go where no woman has gone before, which of course is, I'm shamelessly stealing from Star Trek. And I want to talk about two women, one of which is me and one of which is Jeannette Piccard, who is arguably more interesting than I am, and certainly far more courageous in many ways. So Jeannette Ridlon Piccard was the first woman to fly into the stratosphere, and that was in 1934. And she was both a chemist and a psychologist, and she successfully went and came back, which is, as I tell her story, is an important part of the story. She went and came back to a place where very few people had been so far, and certainly where no woman had gone before. And so I would like to talk a little bit about the history of her expedition, but also about some of the research that I've done that intersects with the spaces that Jeannette has been in. Let's see. So space, the final frontier. So to give us some idea about what we're talking about here in terms of where we are in the atmosphere above the Earth. So we're sitting down here, somewhere I'm 400 feet above sea level in Bryn Mawr. The stratosphere is up here where the ozone layer is. It's above more or less where commercial jets fly. Jeannette Piccard went to 17.5 kilometers, so 11 some odd miles up into the atmosphere. And she would hold that record for almost 30 years until Valentina Tereshkova, who was the woman cosmonaut in Vostok 6, would go up to 212 kilometers. So Valentina sometimes said that Jeannette was the first woman in space. But these days we would not count where Jeannette went to either as space or even as near space. The Kármán line is at the top of this diagram. I'll say one thing about Valentina when we're talking about courageous women. When she returned from the orbits that she made at 3 days in space in Vostok 6, the protocols called for her to bail out at 4 miles above the Earth's surface and parachute down the rest of the way to land successfully. To me, that's somebody who has an incredible amount of courage. And we'll see Jeannette similarly is pretty undaunted by what faces her. So who was young Jeannette? So young Jeannette Ridlon, before she was married to Jean-Félix Piccard, was a rebel from her early days. She told her mother at age 6 that she wanted to be an Episcopal priest, which apparently led her mother to require smelling salts because she, drew faint at the thought that her child wanted to do something that men were only supposed to do. She was never daunted by long odds. She went to an all-girls high school outside of Chicago, which is known just as the high school in Evanston, Chicago. And she discovered that her diploma entitled her to attend any college in the country except one, Bryn Mawr College, which is the college at which I teach. But undeterred, she applied to Bryn Mawr and she failed nearly every entrance exam the first time she took them. So at that point, we had entrance exams. We didn't care what your transcript said. We wanted you to sit for exams. People came in September, sat for exams, and the president herself went through the results and sent students home. So she prepared for another year at the Mrs. Shipley School, which is still here. And in fact, my youngest son taught at it for a year. And she entered Bryn Mawr as a member of the class of 1918. And she was never really an exceptional student. Her transcript is sitting here, which the registrar kindly pulled up for me, but we won't show her grades. Even because, privacy, right? But I can show her transcript of the courses that she took. And she took a significant amount of chemistry and physics as well. So she essentially double majored in psychology and chemistry and physics. And this would play a role for her in the work eventually she would do with NASA. So me too was a little bit of a rebel. I'm going to say that my journey perhaps started with a lot of science fiction, and the most memorable book from my childhood is this one called Have Spacesuit Will Travel, where the two protagonists are a young man very interested in math and a prodigy of a mathematician, a young woman. And they have adventures on the moon, on Pluto, and various other spaces. And the cartoon at the bottom is from a cartoon done by the Science History Institute about chemistry sets and improvisational chemistry. And I ended up telling the tale of electrolyzing water with my brother Patrick, testing the hydrogen. And this plays a part in the story later, a little bit of H2, and you put a burning splint into it, a little piece of wood, and you should hear a pop. Well, we heard a pop all right. I had a lot more hydrogen than we thought, and I singed my brother's eyebrows off. And so my brother's now a computer scientist, and there's probably a reason he doesn't do experimental science. And I suspect that that experience might have been it. But so I was a bit of a rebel too. And this is all happening around the time that Apollo is landing on the moon. So Jeannette finished at Bryn Mawr, returned to the Chicago area to pursue her graduate work in chemistry at the University of Chicago. In 1919, she defended her master's dissertation, which was on the constitution of the Mary-Quinoid salts. And then she married one of her professors, Jean-Philippe Piccard. And he was a Swiss chemist. His twin brother, Auguste Piccard, had made the first successful crewed flight to the stratosphere in 1930, or will make it. I guess at the time they got married, he had not yet done that. And this is Auguste here. So, this is kind of a silly picture with his assistant with the silly balloon hats. And you can see the gondola behind them. So when we think about these kinds of balloons, we're not thinking about the kind of balloon that you see in the early morning with a little basket at the bottom. We're thinking about things that look a lot more like modern spacecraft. And I'll show you some pictures of what these look like. This is Jeannette with Jean-Philippe. And this is Jean-Philippe, and this is Jean-Luc Piccard. And you might be wondering what Jean-Luc is doing in all of this. And perhaps you have noticed that Piccards, Jeannette and Jean-Philippe, also have the same last name as the captain of the Starship Enterprise. And their most enduring legacy might not be in science, but really in science fiction. Gene Roddenberry, who was the showrunner for Star Trek, said that he named the captain of the Starship Enterprise Jean-Luc Piccard And then the legend goes that this was inspired either by the exploits of Piccard's husband, Jean-Philippe, or his twin brother, Auguste. But I would like to make the argument that I think it's actually Jeannette Piccard that he really had in mind rather than Jean-Philippe, and I'll try to make that case at the very end of this talk. So I may have not been a pioneer in the same sense that Jeannette was by going where no woman has gone before, but I did work with pioneers, and this is Sherry Rowland, who was a professor at UC Irvine. He won the Nobel Prize in chemistry for the ozone layer, for understanding how chlorofluorocarbons impacted the ozone layer. He was also my freshman chemistry professor, and then later taught me in graduate school. And I had the privilege of collaborating with him on a piece of work actually I'll talk about. So my interest in the stratosphere begins long before I came to Bryn Mawr and long before I knew about Jeannette Piccard. So Jeannette and I both landed at Bryn Mawr working in chemistry. This is the chemistry lab that Jeannette would have worked in. It was on the third floor of a building, and today I'm going to give it's no longer a laboratory, but now a large lecture space, and I'm going to give my students a midterm exam in that space today. And before we start, we'll talk a little bit about Jeannette. So maybe I'll stop and say a little bit about what I do, which is not balloons or exploring the stratosphere in person. I'm a quantum mechanic, which sometimes my students think I repair broken quantums. But in fact, what I really do is this. I explore a space. The space is a mathematical one rather than the one that surrounds the planet. And I solve that long equation down at the bottom, which is essentially a differential equation. It's a little hidden, but it's a differential equation. And from that, I can generate a surface. I can generate a space that I can explore and find interesting positions on here. So, for example, this sort of well here corresponds to a molecule that you should be able to identify something that's stable. I can identify these kind of mountain passes, which have something to do with the speed of reactions. And this uses everything, I can do small calculations on my desktop computer, but larger calculations need large clusters of, so essentially a supercomputer. So some of these were done on supercomputers. Some of these are done on what are called Beowulf clusters, large numbers of CPUs hooked together to work in parallel. I'm interested in molecules that don't behave properly. So in this, I'm like Jeannette, I'm interested in the things that violate the rules. And here are some of the molecules I've worked on. Dina mentioned that I work on molecules that are topologically intriguing. This is one of them. It's shaped like a Möbius strip. So it has only one edge and one side. And it has some unique and interesting properties to it that I'm not going to talk about, but I thought it'd be nice to show. So this is what I did with working with Sherry Rowland. So it's looking at a molecule called chlorine nitrate. So here's the nitrogen, that's the purple, and then the red spots here are oxygens, and the green is a chlorine atom. And this was proposed as a potential intermediate for moderating chlorine concentrations in the stratosphere. And the question is, is it stable? If it is stable, what are some of the characteristics that could be used to identify it in the stratosphere? And then the last thing is that it has possible isomers. So there are two possible, or there's actually more possible forms, but we're investigating these two possible forms for the molecule. And so computationally, I could create a model. I could solve that big differential equation, and I could then predict both the structure and the properties that you would have to look for if you were looking for this in the stratosphere. And the interesting thing is the one that's got two oxygens, the red to red linkage in it, is a peroxide. And this might be expected to photolize in the stratosphere far more rapidly in the wavelength range that would be of interest. And so we were interested to know which of these two forms it might take. And it turns out that it takes the more stable form on the left, not the peroxide form on the right. And so we can now provide them with the information they need to identify this molecule in the stratosphere. And it was really fun to be a small part of that huge project of trying to understand the chemistry of the stratosphere, a spot that it's not so easy to get to even today. If you think about it, if you want a sample of air from the stratosphere, how do you get it? One way to do it is you send a balloon up and have it open a canister at a particular altitude, close the canister, come back down, and then chase the canister. You have to find where it came back down. This can be challenging. It's more of an adventure for graduate students than working in a computational lab. The other molecule that I worked on that's of interest to things in space is this molecule N4, which is just 4 nitrogens put together, 2 nitrogen molecules, which of course is some stuff that's in the air we breathe. Most of the air we breathe is nitrogen. And here we were trying to figure out, would this molecule be stable? If so, how stable would it be? It's also a very high energy molecule. So people were wondering if this is a way to store energy compactly. High energy molecules are sometimes also used for rocket fuels. And so we explored this surface pretty thoroughly. And here's a bunch of different pieces where we looked at the structure of the molecule. And we were able to show that it is indeed a stable molecule. It is indeed incredibly high energy. If you put this in a bottle, you would not want to drop the bottle. So let's go back to Jeannette Piccard and these balloons. I'd like to point out that these balloons were a really high-risk endeavor. We tend to think of balloons as, an early morning with champagne breakfast event, but this, in fact, was really high risk. So this is Explorer 1, which went up on July 28, 1934, with 3 Army men on board. Albert Stevens was an observer, and Kepner and Anderson were crew and captain. They reached an altitude of over 18,000 meters, so over 60,000 feet, and then the balloon failed. So you can see the launch of this balloon here. So the balloon was launched in South Dakota at a place called the Strato Bowl. And part of the importance of that is you can see that there's this sheltering area here that shelters it from the winds as it goes up. So if you want to send a balloon up, you can't send it up if the winds are high. This will play a role for Jeannette. So they got up to 60,000 feet and the fabric of the balloon failed and they had to return. The balloon then ruptured and they began a very precipitous descent. There was finally a spark that caused the hydrogen in the balloon to ignite and destroy the rest of the balloon. So now they are in this capsule, again, I'll show a picture in a minute, that's plummeting toward the ground at a terminal velocity. And the crew has parachutes, and the last man bailed out at 500 feet above the ground. The capsule was almost completely destroyed upon impact. So this was pretty terrifying to think about. And not much longer after that, but a little bit before this, in 1934, on January 30th, same year that Jeannette Piccard would go up, the Russians sent up a balloon. You can see the crew here standing on the top of their capsule. You can see the balloon going up, and this is the balloon. It crashed. It reached 72,000 feet, 22,000 meters. As they began to descend, the balloon lost its buoyancy. It started rotating rapidly and plunged into an uncontrolled fall. The whole balloon disintegrated in the lower atmosphere, and the 3 crew members failed to bail out and were all killed. So this is the background into which Jeannette is making her ascent. So as promised, this is a picture of one of the gondolas. So this is the second gondola sent up by the US Army Air Corps. And you can see the inside of it. This whole thing is 10 feet in diameter. The largest axis is 13 feet. And you can see in here, this is actually a drawing of Auguste Piccard. You can see that that is really tight quarters in there. And there's some nice photographs of this from the National Geographic and at the Smithsonian Air and Space Museum. So following Auguste Piccard's 1933 Chicago flight, which was done from the World's Fair, they took up from Soldiers Field in Chicago. And you can see the launch of that balloon there with all the spectators in the stadium. Jeannette and John Felice found that they had access to a balloon, a gondola, and a desire to aim for the stratosphere themselves. And given the failures, Jeannette Piccard decided that she would change the design of the capsule a little bit, in part to ease exit. If you had to get out of that capsule in a hurry, could you do this? She still used H2 as the lift gas in the balloon. The Hindenburg would not explode until 1937. So people were not yet totally off putting hydrogen in balloons, but we were getting close. She trained to become the first woman pilot, licensed balloon pilot in the United States, and starts talking this up. And her famous, husband's twin is not going to participate. National Geographic Society had sponsored the previous 2 American expeditions, but in fact, they would have nothing to do with this expedition because they didn't want to send a woman, in particular a mother. Jeannette had 3 sons at this point, in a balloon into danger. So unfortunately, all they had was their balloon, their gondola, and not much more than that. And this was not an inexpensive endeavor. The 1933 flight had cost $50,000. That's in 1933. And they needed to raise another $10,000, which would be about $200,000 in current US funds to cover the cost of another flight. They were not attached to an academic institution or a commercial laboratory or a military research facility, and this was the height of the Great Depression. So there was no obvious way to pursue funding, and it turns out that John Felice had a rather, shall we say, difficult personality, and the catastrophic ends to the more recent attempts did not help. So, but Jeannette was pretty determined, and like her entrance to Bryn Mawr, she was going to keep at it until she got in. So she started aggressively pursuing family connections in Chicago in an attempt to just fundraise. She essentially ran the Kickstarter of the 1930s. She convinced the Ford Airport outside of Detroit in Michigan to provide them with free housing and launch services. She got the local aviation community to come out for her and managed to get an all-volunteer ground crew of 300 people to cover the rest of the launch needs. The Edison Manufacturing Company, so associated with Thomas Alva Edison, donated the anchor system for the gondola, and she got a gas company, Burdett Oxygen, to supply the hydrogen for the balloon at a discount. And she needed hundreds of canisters of H2 to launch this balloon. She also ordered what they called covers, or short pamphlets describing the flight, which then she planned to take into the stratosphere and sell for $25 a piece when they got back. She made her husband write articles for a newspaper syndicate. And long before the internet, she managed to fund the whole thing in all of this. And so here are some of the covers that came back. This is number 530. And you can see that it's postmarked from Cadiz, Ohio, which is where they landed. And this is via airmail, right? It says on there. So not a plane, but a balloon. Weather is critical, and without the shelter of the stratobowl that the Army Air Force had at their base in the Badlands, their flight was delayed. So they had planned to go off in September, but in fact, they did not go until October. And they did not have weather bug or any of the things that we have to track the weather. So this is the weather map that came from her log, and they're watching to make sure that they have low enough winds so they're not destroyed on going up into at the ground level, they have no idea what the winds in the stratosphere are going to be. These days, we're sampling and sounding that, so we know what the jet stream is moving at. They had no idea what they were getting into. So she finally had all of her backing. They had good weather projected early in the morning of October 23rd, so almost a month after their planned launch. And this is her pre-flight checklist. And so this is actually from Jeannette's papers, which are, there are copies at both the National Archives in DC, but also at Bryn Mawr. So I went rooting through Jeannette's papers, and includes a copy of the flight log. At the beginning of the flight log is, what should you check? You should check that you have the chemicals for purifying the air. You should check that you've got your husband's reading glasses, flashlights, shoes, hot water, so you can make a cup of tea on this. And fleur-de-lis. Fleur-de-lis is her son Don's pet turtle, and apparently the mission mascot. And all this needed to be stored in the capsule before they took off. She had some information about the final operations she needed to do with the cosmic ray pieces. The one thing you might note on there, it says remove the cover of the top window. Despite her flight safety checklist, she in fact forgot to take the window cover off, and she would have to climb out in flight to take it off so that they could take the photographs that they wanted to take. So she would climb out on the top of this gondola to do that. So here they go. They're up at 6:58 in the morning. This is her handwritten flight log. And this is a shot through that window that you can now see through because the cover is off. And you can see that the balloon is not completely inflated. It's essentially this long oblong at the lower part of the atmosphere. It will inflate to be completely spherical when it hits the stratosphere. She says at 6:27, so she's blown her time. They took off at 6:58, so this can't possibly be 6:27. And when she makes a typed transcript of her flight log, she will correct that. But at 7:27, they were nearly through the cloud deck. They were climbing at 200 feet a minute. And she writes that they were revolving, and she has slowly, which she crosses out, and then writes rapidly. Rapid rotation of the capsule had played a role in the crash of that Russian stratospheric attempt. So this must have been, at the very least, worrying to Jeannette that they were undergoing this kind of rotation. Outside, the temperature was 5 degrees C, and inside it's nice and toasty, 58 Fahrenheit. And I find it interesting that she's measuring in two different units as she does this. So here is the typed transcript made after, about November 7th, this transcript was made. And there's a correction of the time, right? She's corrected it from 6:27 to 7:27. And she notes here that she climbed into the gondola, saw the top window was not free, and climbed out again to remove the cover of the window. And here you can see them taking off. And this is Jeannette standing on top of that gondola as they are releasing it, and she is going to go up into the air. There's film footage of this, and I'll give you the link at the end of the talk. It's a half-hour interview with Jeannette. It's just fabulous. But you can see her going up quite a distance as she's standing on top of the gondola, and then we'll have to crawl in through this hatch on the side. It's unclear to me whether she's wearing any kind of safety gear as she does this. I think she's just scrambling back in. By 8:21, they were at about 10,000 meters, and Jean-Philippe began to make the cosmic ray measurements that Robert Millikan had suggested. They're not sure where they are. She says, we don't know where we are because the cloud deck below them obscures the surface of the Earth. They have a primitive radio, but they're unable to make contact with it. You can see the instruments that they had to use in flight. They have a Geiger counter, a couple of meters for measuring the cosmic rays, and an electric thermometer to record the outside temperatures. So this was like the hottest gear that they could get to do these measurements. 3 hours later, It's 11:21. The outside temperature is minus 49 degrees C. Inside, it's still 66. And again, she's still measuring in Fahrenheit. There's no more ice on the walls, she reports. The inside of the gondola had began to ice up. And you can see that the balloon is beautifully inflated. You're seeing this through the harness, the little ring that's on top of the gondola. They still don't know where they were, but they've decided to start coming down. She's afraid that they've gone too far because, again, they have no idea what those stratospheric winds are. And she's afraid if they've gone too far, they'll come down in the Atlantic. If they come down in the Atlantic, there is no rescue plan. So she thinks that now is time to come back down. So they begin their descent. It takes them 3 hours to reach the ground from their final altitude of 17.8 kilometers. They touch down in Cadiz, Ohio, 300 kilometers from their starting point. And they landed essentially in the woods outside of a farmer's field. And the farmer and some of the local kids came running to see this thing coming down. And she got their signatures in her log to note, where exactly they landed. John Fulton Farm. And here it's 4.5 miles southwest of Cadiz, Ohio. And she gets the signatures of the people who were there. And here's the capsule. It's once again open. And here's Jeannette. You can't see her husband behind her talking to her. So they successfully landed. The landing was rough enough to break bones. Jean suffered a cracked rib and the balloon was shredded, but the capsule was intact and the Piccard's alive. So this was a success. Still, Jeannette was pretty distressed and she wrote a piece for the New York Times on it, which she drafted at the end of her flight log. And she says, my most vivid sensation with regard to this flight is one of shame that she didn't offload the ballast quickly enough to clear the trees. But given the disastrous outcomes of the previous 2 attempts that year, I think it was a brilliant success. And she set the altitude record for women, which would not be broken until Tetraskova went into space in 1963. Here's her husband sends a message to his brother saying just one word, success. She sends a message to her son who's in school, so was not present at the flight. Flight of success, landed safely, mother. So I think her sons were probably pretty relieved that everyone came out of this okay. So the Piccards had pitched this flight not as an altitude record setting flight, but as a chance to do science, to investigate the identity and source of the, at that time, mysterious cosmic rays. So they were going where no one went before, but the goal was, in fact, to do science, to find strange new worlds, or at least strange new phenomena. The trouble was that none of it was usable. And in part, that was because Jean-Philippe, who was in charge of doing the experiments, failed to follow the protocols and failed to keep accurate records. And so here's one of the protocols that he took up. You notice it says pull out A. There's a diagram on a previous page that shows you the instrumentation and what you're supposed to be doing. At 10 o'clock, Jeannette writes in her flight log, I can see an opening in the clouds. And at 10:11, found we had forgotten, she notes, but she's not in charge of these experiments, he is. So found we had forgotten to pull out A, did so, 10:12. But this would be characteristic of the work that was done. After all this work to get that balloon up, after all that work to raise the money, indeed, there would be no science that one would get out of it. But despite all of this, it would indirectly leave its mark on extraplanetary science. So the technical report that they wrote after this flight had a couple of pieces in it that were important. And it discusses at length the design of apparatus to remove carbon dioxide from the balloon capsule's air. Because of course this thing is sealed up. And so you want to make sure that you're not breathing your carbon dioxide. And previous expeditions had issues with this, where occasionally they had to sort of open the capsule and flush it. And of course, you're at very low pressures up there, and that has issues as well. And at least one expedition nearly died from CO2 poisoning. But in a very eerie foreshadowing of the disastrous failure of Apollo 13's carbon dioxide scrubbers, she notes that they had rejected the idea of reconditioning the air by blowing it over the granulated potassium hydroxide. And she says in her report, something may go wrong, which will need repair, which is, of course, exactly what happened to Apollo 13. Something went wrong, which needed repair. She eventually was drafted to help write a proposal for the design of the doors for Gemini. So they were worried about ability to get out those doors. And because exit from the capsule in these balloons had been an issue in several crashes, and because she had helped to design the doors for these capsules, she was consulted by NASA. And this is part of the report, a proposal for design of the doors of Gemini. What I love is that in that report, she quotes Gertrude Stein. Engineers are poets who use hardware and color instead of words as a medium of expression. She was the quintessential Bryn Mawr student. This report talks both about the engineering challenges, but it also talks about the psychological challenges. How can you design a door or a hatch that in an emergency is the way you think it should work? So she's already thinking about the intersection between training and reactions in an emergency. And so I love the way that science, psychology, social sciences, and the hard sciences really meshed in Jeannette's work. There's another kind of piece of Bryn Mawr history that goes with this. So Jeannette would go on to consult with NASA in the 60s on capsule design. Eventually, lunar material would be brought back from the Apollo missions that her work helped make possible. And some of those pieces of rock would be returned to Bryn Mawr, Jeannette's alma mater, for analysis by one of my colleagues, Maria Louisa Crawford, who was a MacArthur Fellow and who worked on the moon rocks. She's a petrologist. Here she is in the field, not on the moon, but in Alaska. So my argument might be that Jean-Luc Piccard is really named for Jeannette. Jeannette, Jean-Luc. Jeannette, Jean-Luc. She was the pilot. She was the captain of this ship. And Jean-Felice was a little bit maladroit, shall we say. You know, he was the perhaps red-shirted engineering ensign who didn't quite manage to pull out the plugs when he was supposed to pull them out. So I'm going to think that Jean-Luc Piccard is really named for Jeannette Piccard. And I hope you agree with me. So I'd really like to thank everybody for their attention, for coming this morning. I'd like to thank Bryn Mawr, particularly the Bryn Mawr College Special Collections, who hauled out all this material on Jeannette Piccard for me. Michael Dene, who's a historian who assisted with this. He helped transcribe some of the flight logs. The Specola Vaticana, which supports this kind of writing that I do, along with the Klaus Fund for Science and Public Policy and the National Science Foundation. And thank you, everybody. And the last thing I'm going to do is I'm just going to put this up. This is a half-hour film from balloon to gondola, which is an interview done by NASA with Jeannette Piccard. It's got tons of footage in it. It is so worth watching. If you just search from balloon gondola, NASA and Jeannette's name, you'll get it. And I'm not going to show it. There we go. But it's really a terrific, terrific piece.
Thank you very, very much. Let's see. Maybe if we can stop sharing screen, we can see each other a little bit better and we can take some questions.
There we go.
Awesome. Thank you. So are there questions? And you can type them in the chat as well, or if you want to raise your hand, you can raise your hand. I think I will start. I was wondering, Michelle, if you had seen the movie The Aeronauts that came out a few years ago?
I did, but I had a really hard time watching those people standing on the outsides of balloons.
That was taken, that took place far earlier than what
Yes. Right. So this ballooning stuff had been going on, and a lot of chemists were doing this ballooning because they were interested in the properties of gases, and that was a way to get to low pressures. So there, Charles' law is an important law in gases, and he set one of the altitude records going up in these balloons to take samples. So there's a long history of science and ballooning being intertwined with each other.
I think it's fascinating, especially given that I think now people would like send up a GoPro and do it in a more probe-like, robotic-like way.
Yep, and they're going up all the time. We're sending these balloons up to sample stuff for weather. People are sending them up to sample stuff from the stratosphere. It's all robotic, you know, little things trigger. You track it with GPS when it comes down to Earth. So yeah, it's very different. You don't need to send a human up. Although occasionally there still have been expeditions. The Red Bull guy who went up and, you know.
Felix Baumgartner, I think.
Yes, that's exactly who.
And that was not what Jeannette Ridlon Piccard was doing. Did she got her husband to speak English with her? I was kind of wondering about the interlinguistic marriage.
Well, he was teaching at the University of Chicago, so he was teaching in English when they were married.
So he was an expert.
He was an expert, and I'm guessing her transcript doesn't show her taking French or German. Well, no, I'm sorry, it does actually show that she took German. So I'm wondering if that was kind of the language of the household.
If he was Swiss, yeah, it could go either way.
Yeah, it could be either way, but he was definitely teaching in English. And I don't think I have any interview footage of him, but he was writing articles in English as well.
Right. That's just me because I'm a language person too. So. Other questions from the assembled folks? There are quite a few of you here.
Watch the video. I mean, watching her climb out as that thing is going up into the air is just amazing.
If you have the link to the video, maybe we could put that in the chat as well.
Oh, yeah, perfect. I can do that. Let me pull that up.
So I'm looking at all of you, especially if I know you and you haven't raised your hand, you're going to hear about it. So.
Do you own your home, but still rent your electric?
Whoops. Okay, that was me because I brought up the thing to pull the link down.
Okay, Michelle, I don't know for multitasking, but we do have a question. There we go. I see it. There's a question in the chat from Marcy Frumker. Any evidence that Roddenberry was actually thinking of Jeannette Piccard for Captain Piccard's character?
There is no evidence beyond my own speculations. There's really only just the briefest of evidence that he was referring to the Piccards, but they continue to be a family that was involved in undersea exploration. Her son, Don Piccard, was also a balloonist who made a number of flights, you know, round the world balloon flights. So the name Piccard and adventuring certainly are related to each other.
Yeah, I definitely think that. Glenn, I see you're there. Did Gene Roddenberry come up with the character of Jean-Luc Picard?
I'm assuming so. Can you hear me okay? This is
yes.
The first video that
Glenn's one of our co-organizers, my husband, and our resident Star Trek expert. So Michelle and Glenn, I'm introducing you.
Hello.
Hello. Yeah, no, I can actually find a hard reference to Roddenberry saying that it was related to Piccard, but I can't. The name's Piccard, but no first name is attached to it.
Yeah.
Yeah.
I think he probably wanted to make it more universal, you know, I mean, still be Piccard, but yet not that necessarily, you know, be a male or female so that it could be up to the audience.
Right. I think there was a lot left there. And Jean-Luc Picard is French, not Swiss.
Right.
So I think there's definitely some attempt to separate them.
But if you want a masculine version of Jeannette, Jean is what you get for sure. So.
Yeah, no, I mean, I just feel like, you know, you have two syllables, you know, anyway, I enjoy thinking about it.
Probably true. Other comments or questions out there? Oh, go ahead. Mrs. George.
Well, good morning. And Michelle, thanks for that wonderful presentation. as someone who has been a hot air balloon enthusiast, is the Piccard Balloon Company that exists today a spin-off of some of their scientific adventures, or maybe another family member took that on, or some enterprising entrepreneur decided to capitalize on the famous ballooning family name? Do you know?
I think it's a spin-off from her son, from Don Piccard.
Uh-huh.
And I don't know if he actually founded it or whether he was just associated with it. And I didn't follow Don's career much beyond sort of this, notion that he definitely followed in the footsteps of his parents, and particularly his uncles, in all of this.
Yeah. So the other comment I wanted to make was, this is a fabulous example of how individual initiative, despite minimal funding, can actually lead to some very exciting exploration. And nowadays we think of investigators that are well known and famous worldwide and have more funding than most people could ever dream of. And yet many adventures and explorations start out with this kind of personal ambition, perseverance, sometimes fortuitous ignorance, to continue to pursue this, whatever their curiosity is.
Yes, I 100% agree.
Yeah. So thanks for digging into it and pulling all those little details out, and the very important human interest part of this whole adventure.
Yeah, my students enjoyed reading her flight logs to see, that she covered everything from what the color of the sky was, and at the end she was, concerned about retrieving the turtle from the capsule.
Right.
Right. That's actually a detail that's reported in the New York Times, that the fleur-de-lis was, rescued from the capsule before she was willing to, haul stuff away.
Well, the captain doesn't leave until all the other crew members are out.
Correct. Absolutely. And that was an important crew member. But I think too, there are in fact now the equivalent of a scientific Kickstarter, where people can seek funding for these small kinds of projects. But I mean, the kind of personal investment that you see is, right, I think, an equal version of courage to climbing up on that gondola.
Indeed. Well, thanks again.
Thank you.
Thank you, George. Other questions, other comments? You can put something in the chat, or you can go ahead and raise your hand or just begin speaking. So have you ever, Michelle, considered or have done any chemistry at a high altitude in an experimental way?
I've been part of groups that have done that. But I've always been the computational person working with the data that came back. My son was part of a theater expedition where they wanted to try to launch a balloon into the stratosphere. And I did some advising for them on a design of something that would, easily measure their altitude and tell them what their maximum altitude they'd achieved was. So I designed this little gadget for them. They sent the whole thing up. And it came down, they were doing this in England, and it came down in a military zone, and they were unable to retrieve it. Yeah. They actually were, I said you should just call the base and ask, and they were afraid to do that because of course they had, now violated some kind of, airspace with this.
They didn't want to self-identify at all.
Correct, absolutely. I, was like, are you sure? Because I would be really curious, did my device, so I still don't know, did my device work, right?
That's got to be frustrating.
As a scientist, it was totally frustrating.
Yeah, you've got to get that data back. I don't know, you'll have to figure out if they're still away. It's probably too late, but.
I suspect it's too late, but I still think, the difference between the theater people are like, we're just not going to say anything, and we'll hope there are no fingerprints on it at this point. And me, it's like, but we want the data.
Yeah, if they were chemists, they would have gotten it, right?
Oh yeah, for sure. And
Well, thank you so much. I think if there aren't any other questions, I'm going to first off a little bit of housekeeping. There's a link in the chat about a survey. We're going to be doing these throughout the day. So if you want to give us some feedback about this presentation, it helps us with our funding and things like that. And also, I wanted to thank Dr. Francl so much for the presentation. It was fascinating. The combination of having this kind of historical perspective and the contemporary aspects of science, and seeing somebody whose life really went through this range of what was scientifically possible and continued making contributions is just fascinating and inspiring. So thank you very, very much for that.
You're welcome. Thank you for having me. This was great fun to do. And it was great fun to dig into Jeannette's life once again.
I'm seeing some clapping, virtual clapping, they're out there. So thank you very much. And I'm going to move everybody into a breakout room that's a waiting room. And the next talk will start at 9:30 with Catherine Newell. So looking forward to that. And thank you, Michelle, for being our inaugural speaker for Roger That 2022. Much appreciated.
Thanks so much for having me. And may the rest of the day go well. I look forward to hearing some of the other talks. So
we'll see you.
Excited to do that. See everybody. Bye.
Bye.